Welcome to our tranquil journey around the vast perimeter of the Pacific Ocean, where a chain of volcanic peaks and earthquake zones forms what geologists call the Ring of Fire, a 40,000 kilometer or 25,000-mile horseshoe of tectonic activity that encircles the world's largest ocean basin. As you settle into comfort tonight, allow your mind to drift slowly along this immense geological boundary, where the patient movements of Earth's crustal plates create the mountains, islands, and deep ocean trenches that define the Pacific's rim. This remarkable feature encompasses approximately 75% of the world's active volcanoes and 90% of the world's earthquakes. Yet, despite this seemingly dramatic activity, the processes that drive the Ring of Fire unfold with the methodical patience that characterizes all geological phenomena, measured not in human timescales, but in the gradual accumulation of millimeters of movement each year. I wonder where you might be listening from this evening, what part of our world you call home, and what time your clock shows as these words reach you. Perhaps you might share that peaceful information with us in the comments below, creating our own gentle map of listeners scattered around this remarkable planet. And if you find that these geological wanderings bring you the rest you seek, consider subscribing to join us on future explorations of Earth's most soothing yet magnificent landscapes. The Pacific Ring of Fire extends in a great arc from New Zealand northward through the Philippines, Japan, and the Aleutian Islands of Alaska. Then southward along the western coasts of North and South America, creating an almost complete circle around the Pacific Ocean basin. This immense geological feature results from the interaction of several major tectonic plates, including the Pacific Plate, the largest of Earth's crustal plates, covering approximately 103 million square kilometers, or 40 million square miles of ocean floor. The Ring of Fire represents the boundaries where these massive plates meet, grind against each other, and either collide or separate at rates typically measuring between 2 and 10 centimeters, or 0.8 to 4 inches per year. Movements so gradual that they remain imperceptible to human observation, yet accumulate over geological time to create the most dramatic topographical features on our planet. The formation of the Ring of Fire began approximately 200 million years ago during the breakup of the supercontinent Pangaea, when the processes of plate tectonics began reshaping the Earth's surface into the configuration we observe today. The Pacific Plate, born from ancient spreading centers in the ocean floor, has been slowly moving northwestward for tens of millions of years, encountering and sliding beneath the surrounding continental plates in a process called subduction. This subduction occurs when the denser oceanic plate descends beneath the lighter continental plate, diving into the Earth's mantle at angles typically ranging from 30 to 70 degrees, and reaching depths of 660 kilometers or 410 miles before the descending slab becomes fully incorporated into the mantle's convective circulation. Along the western edge of the Ring of Fire, the subduction of the Pacific Plate beneath the Eurasian and Philippine plates has created some of the deepest ocean trenches on Earth, including the Mariana Trench, which reaches depths of 11,034 meters, or 36,200 feet below sea level. These trenches form where the oceanic plate bends downward as it begins its descent into the mantle, creating elongated depressions in the ocean floor that extend for thousands of kilometers, parallel to the volcanic island chains and mountain ranges that mark the Ring of Fire's boundaries. The Mariana Trench alone stretches for approximately 2,550 kilometers, or 1,580 miles, across the western Pacific, its maximum depth exceeding the height of Mount Everest by more than 2 kilometers, or 1.2 miles. The volcanic activity that characterizes the Ring of Fire results from the gradual melting of the descending oceanic plate as it encounters the increasing temperatures and pressures of the Earth's interior. As the subducted plate descends, water trapped in its crystalline structure is released at depths between 100 and 200 kilometers, or 62 to 124 miles, lowering the melting point of the surrounding mantle rock and creating magma that slowly rises toward the surface. This process typically requires thousands to millions of years for completion. As the magma makes its gradual ascent through the overlying crustal rocks, cooling and crystallizing along the way before finally reaching the surface to create volcanic eruptions. The island chains that dot the western Pacific represent the surface expression of this deep geological process, with each volcanic island built through countless eruptions spanning millions of years. The Japanese archipelago, stretching approximately 3,000 kilometers, or 1,900 miles, from northeast to southwest, contains 108 active volcanoes distributed across 4 main islands and numerous smaller ones. Mount Fuji, perhaps the most famous of Japan's volcanoes, rises 3,776 meters, or 12,388 feet above sea level, and has been built through eruptions spanning approximately 100,000 years, with its current symmetrical cone shape developing over the past 10,000 years through the accumulation of lava flows and pyroclastic deposits. As our minds traverse these volcanic landscapes, perhaps you might reflect on what draws you to such dramatic yet peaceful geological features. What aspects of mountains and volcanic islands bring you a sense of tranquility despite their fiery origins? If you feel moved to share such thoughts in the comments below, many would find comfort in reading about the landscapes that soothe our restless spirits. The Philippine archipelago represents another magnificent example of Ring of Fire volcanism, with approximately 7,640 islands distributed across 300,000 square kilometers, or 116,000 square miles of ocean. The islands are arranged in 3 main groups, each reflecting different aspects of the complex tectonic processes operating in this region, where multiple plates converge and interact. The largest island, Luzon, contains 47 named volcanoes, including Mount Mayon, which rises 2,463 meters, or 8,081 feet above sea level, and displays the classic cone shape that results from consistent eruption patterns over thousands of years. The perfect symmetry of such volcanic cones develops when eruptions consistently deposit material at the same angles around a central vent, creating slopes that typically range between 30 and 35 degrees from horizontal. The Indonesian archipelago extends the ring of fire southward and eastward through more than 17,000 islands scattered across 1.9 million square kilometers, or 735,000 square miles of ocean. This vast island nation sits astride the meeting point of 4 major tectonic plates, creating one of the most geologically complex regions on Earth. Indonesia contains approximately 130 active volcanoes, more than any other country, including Krakatoa, whose 1883 eruption produced sounds heard 4,800 kilometers, or 3,000 miles away, and created atmospheric pressure waves that circled the globe 7 times. The volcanic soils created by thousands of years of eruptions have made many Indonesian islands extraordinarily fertile, supporting dense populations despite the ongoing volcanic hazards. Moving eastward along the Ring of Fire, the island chains of Melanesia and Polynesia represent some of the most remote volcanic landscapes on Earth, where individual volcanoes rise from ocean depths exceeding 4,000 meters, or 13,100 feet, to create islands that may rise only a few hundred meters above sea level. The Hawaiian island chain, though not technically part of the Ring of Fire, due to its hotspot origin rather than subduction zone formation, demonstrates similar volcanic processes on a magnificent scale. The Big Island of Hawaii contains 5 major volcanoes, including Mauna Loa, which rises 4,169 meters, or 13,678 feet above sea level, but extends approximately 9,000 meters, or 29,500 feet from its base on the ocean floor, making it one of the largest single mountains on Earth by volume. The northern arc of the Ring of Fire extends through the Aleutian Islands of Alaska, a chain of more than 300 small volcanic islands stretching 1,900 kilometers, or 1,200 miles, across the North Pacific. These islands experience some of the most severe weather conditions on Earth, with constant winds, frequent storms, and fog that obscures the landscape for much of the year. The volcanic peaks rise directly from the stormy ocean, their slopes often shrouded in clouds that deposit more than 2,500 millimeters, or 100 inches of precipitation annually. Despite these harsh conditions, the volcanic activity has created remarkably uniform cone shapes that demonstrate the consistent nature of eruptive processes, even under extreme environmental conditions. The eastern boundary of the Ring of Fire follows the western coasts of North and South America, where the subduction of oceanic plates has created some of the world's most impressive mountain ranges. The Cascade Range extends for approximately 1,100 kilometers, or 700 miles, from northern California to southern British Columbia, containing 13 major volcanic peaks, including Mount Rainier, which rises 4,392 meters, or 14,411 feet above sea level, and supports 26 named glaciers on its slopes. The volcanic peaks of the Cascades are spaced at remarkably regular intervals of 50 to 100 kilometers, or 30 to 60 miles, reflecting the uniform spacing of magma generation zones in the subducting plate below. The Andes Mountains represent the most extensive expression of Ring of Fire volcanism, extending more than 7,000 kilometers, or 4,300 miles, along the western coast of South America, and containing more than 180 active volcanoes. The Andes reach their greatest heights in the central regions, where peaks exceed 6,000 meters, or 19,700 feet in elevation, and volcanic activity has built some of the highest volcanoes on Earth. Ojos del Salado, straddling the border between Chile and Argentina, rises 6,893 meters, or 22,615 feet above sea level, making it the highest volcano in the world and the second highest peak in the Western Hemisphere after Aconcagua. The earthquake activity that accompanies Ring of Fire volcanism results from the same tectonic processes that create the volcanic mountains and ocean trenches. As the oceanic plates descend into the mantle, they generate earthquakes at depths ranging from the surface to approximately 660 kilometers, or 410 miles below ground. The deepest earthquakes occur where the descending plates reach their maximum penetration into the mantle, while shallow earthquakes typically result from the fracturing and faulting of crustal rocks as they adjust to the ongoing tectonic stresses. The magnitude and frequency of these earthquakes vary considerably around the Ring of Fire, with some regions experiencing major earthquakes with magnitudes exceeding 8 every few decades, while other areas may go centuries between significant seismic events. The Pacific Plate moves northwestward at an average rate of approximately 7 centimeters, or 2.8 inches per year, carrying the volcanic islands and seamounts created at mid-ocean ridges toward the subduction zones, where they will eventually be consumed by the Earth's interior. This process creates what geologists call the conveyor belt of plate tectonics, where new oceanic crust is continuously created at spreading centers and destroyed at subduction zones, maintaining the Earth's surface area while constantly recycling crustal materials through the mantle. The entire cycle, from the creation of oceanic crust to its subduction and recycling, typically requires 100 to 200 million years, a time span so vast that it encompasses multiple cycles of continental drift and mountain building. Perhaps you have experienced peaceful moments in mountainous regions or near volcanic landscapes that brought you feelings similar to those we explore along this ring of fire. If you feel inclined to share such experiences in the comments, others would find comfort in reading about the geological places that have provided you with tranquil reflection. The thermal features associated with ring of fire volcanism extend far beyond the dramatic eruptions that occasionally capture global attention. Geothermal activity creates hot springs, geysers, and fumaroles that release steam and gases from the Earth's interior at thousands of locations around the Pacific Rim. These thermal features often provide the only visible evidence of the vast underground heat sources that drive volcanic activity, with surface temperatures that may exceed 100 degrees Celsius or 212 degrees Fahrenheit, while the magma chambers beneath remain at temperatures between 800 and 1,200 degrees Celsius, or 1,470 to 2,190 degrees Fahrenheit. The gradual circulation of groundwater through these heated rock systems creates complex chemical processes that can continue for thousands of years between major eruptions. The mineral deposits created by ring of fire volcanism have shaped human civilization around the Pacific Rim, providing sources of copper, gold, silver, and other metals that form when hot volcanic fluids interact with surrounding rocks. These hydrothermal deposits typically develop over thousands of years as heated groundwater dissolves minerals from deep rocks and redeposits them in fractures and cavities closer to the surface. The Kuroko deposits of Japan, formed by underwater volcanic activity millions of years ago, contain some of the world's richest concentrations of copper, lead, and zinc, while the porphyry copper deposits of the Andes provide approximately 60% of the world's copper production. The climate effects of ring of fire volcanism can extend far beyond the immediate vicinity of individual volcanoes, with major eruptions occasionally affecting global weather patterns for several years. The 1815 eruption of Mount Tambora in Indonesia injected approximately 100 cubic kilometers, or 24 cubic miles of ash and debris into the stratosphere, creating the year without a summer in 1816, when global temperatures dropped by 0.4 to 0.7 degrees Celsius, or 0.7 to 1.3 degrees Fahrenheit. The fine volcanic particles remained suspended in the atmosphere for more than 2 years, reducing solar radiation and causing crop failures and famine across the northern hemisphere. The ocean basins created by ring of fire tectonics contain some of the deepest and most voluminous bodies of water on Earth, with the Pacific Ocean covering approximately 165 million square kilometers, or 64 million square miles, and containing more than half of the world's ocean water. The average depth of the Pacific Ocean is 4,280 meters, or 14,040 feet, with maximum depths exceeding 11,000 meters, or 36,000 feet in the various trenches that mark subduction zones around the ring of fire. The vast volume of water in the Pacific Ocean, estimated at 710 million cubic kilometers, or 170 million cubic miles, moderates global climate patterns and supports ocean currents that transport heat and nutrients around the world. The Ring of Fire's influence on ocean circulation patterns creates complex systems of surface and deep water currents that affect marine ecosystems throughout the Pacific Basin. The subduction zones create underwater topography that deflects and channels ocean currents, while the volcanic islands and seamounts provide stepping stones for marine life migrations across the vast Pacific distances. The nutrient-rich waters that upwell along some parts of the Ring of Fire support some of the world's most productive marine ecosystems, including the anchovy fisheries off Peru and Chile, and the salmon runs of the North Pacific. The human populations living within the Ring of Fire have developed sophisticated adaptations to volcanic and seismic hazards, creating architectural styles, agricultural practices, and cultural traditions that reflect thousands of years of coexistence with geological instability. Traditional Japanese wooden construction techniques emphasize flexibility and light weight to minimize earthquake damage, while Andean agricultural terraces demonstrate methods for farming on steep volcanic slopes while controlling erosion and conserving water. These adaptations represent accumulated wisdom passed down through countless generations of people who learned to read the subtle signs of geological change and adjust their lives accordingly. The monitoring systems established around the Ring of Fire utilize networks of seismometers, tiltmeters, and gas sensors to detect the subtle changes that may precede volcanic eruptions or major earthquakes. These instruments can detect ground movements measured in micrometers and temperature changes of fractions of a degree, providing early warning systems that have saved thousands of lives in recent decades. The data collected by these monitoring networks also contributes to scientific understanding of the deep processes that drive Ring of Fire activity, revealing patterns in earthquake sequences, magma movement, and gas emissions that help predict future volcanic behavior. The gradual nature of most Ring of Fire processes means that significant changes typically accumulate over periods much longer than human lifespans, creating landscapes that appear stable and permanent from human perspectives, while actually representing snapshots of ongoing geological evolution. The volcanic peaks that dominate ring of fire landscapes may grow by only millimeters per year through the accumulation of lava flows and ash deposits. Yet over geological time, these incremental additions create mountains that rise thousands of meters above their surroundings. Similarly, the tectonic movements that drive earthquakes typically accumulate stress over decades or centuries before releasing their energy in brief moments of violent shaking that reshape the landscape in seconds. As our mental journey around this vast circle of geological activity begins to draw toward its conclusion, perhaps you might reflect on which aspects of these volcanic and seismic processes you find most conducive to peaceful relaxation. If you feel moved to share such observations in the comments below, many listeners find that reading about what brings others peaceful sleep helps enhance their own rest. The interconnected nature of ring of fire processes demonstrates the fundamental unity underlying apparently separate geological phenomena, where volcanic eruptions, earthquakes, mountain building, and ocean trench formation all result from the same underlying plate tectonic movements. The magma that erupts from ring of fire volcanoes began its journey toward the surface when oceanic crust first subducted into the mantle hundreds of kilometers away. And millions of years earlier, the earthquakes that shake ring of fire regions represent the ongoing adjustment of crustal rocks to stress fields that extend across entire tectonic plates and influence geological processes thousands of kilometers from their sources. The mineral cycles that operate within ring of fire systems connect deep mantle processes with surface environments through the gradual circulation of chemical elements between the Earth's interior and its atmosphere, oceans, and biosphere. Elements such as sulfur, carbon, and chlorine that are released by volcanic eruptions may spend thousands of years in atmospheric or oceanic circulation before being incorporated into sedimentary rocks and eventually subducted back into the mantle to begin the cycle anew. These cycles operate on timescales that span millions of years, connecting current volcanic activity with geological processes that began before complex life appeared on Earth. The energy released by ring of fire earthquakes and volcanic eruptions represents only a tiny fraction of the vast thermal energy stored within the Earth's interior, where temperatures may exceed 5,000 degrees Celsius or 9,000 degrees Fahrenheit at the core mantle boundary. This internal heat, generated primarily by the radioactive decay of uranium, thorium, and potassium within the Earth's interior, drives the convective motions in the mantle that ultimately power plate tectonics and all associated geological processes. The heat flow through ring of fire regions averages approximately 80 milliwatts per square meter, nearly twice the global average, reflecting the enhanced thermal activity associated with subduction zone processes. The sedimentary processes that operate around the ring of fire create some of the world's thickest accumulations of marine and terrestrial deposits, where erosion of volcanic mountains provides vast quantities of sediment that fill adjacent ocean basins and coastal plains. The Ganges-Brahmaputra Delta in Bangladesh and the Mississippi Delta in Louisiana both contain sediments derived primarily from mountain ranges, created by processes similar to those operating around the Ring of Fire, demonstrating how volcanic mountain building in one region can affect sedimentary environments thousands of kilometers away through river transport systems. The biological communities that inhabit Ring of Fire environments have evolved remarkable adaptations to the periodic disturbances created by volcanic eruptions and earthquakes, developing life cycles and dispersal mechanisms that allow rapid recolonization of areas affected by geological catastrophes. Pioneer plant species can establish themselves on fresh volcanic soils within months of eruptions, beginning ecological succession processes that may require centuries to reach mature forest communities. These biological responses to geological disturbance create dynamic ecosystems characterized by high diversity and rapid turnover, where species compositions change continuously in response to ongoing volcanic activity. As our circumnavigation of this immense geological feature approaches its end, we return to the fundamental recognition that the Ring of Fire represents one of the most magnificent examples of the deep processes that shape our planet's surface. The volcanic peaks that rise from tropical islands and snow-covered mountain ranges, the ocean trenches that plunge to depths greater than Mount Everest's height, and the earthquake zones that occasionally reshape entire coastlines, all reflect the same underlying process of plate tectonic movement that has operated for billions of years and will continue for billions more. The gradual subduction of oceanic plates beneath continental margins continues today at the same measured pace that has characterized this process throughout geological history, carrying oceanic crust created at mid-ocean ridges back into the Earth's interior, where it will be recycled into new magma and eventually returned to the surface through volcanic eruptions. This grand recycling system operates with a patience that transcends human understanding, yet provides the fundamental mechanism that maintains the Earth's surface in dynamic equilibrium between creation and destruction, between mountain building and erosion, between the forces that elevate land and those that return it to the sea. The Ring of Fire stands as testament to the power of gradual change, where movements measured in centimeters per year accumulate over millions of years to create some of the most dramatic landscapes on Earth. The volcanic islands that dot the Pacific Ocean, the snow-capped peaks of the Andes and Cascades, and the deep ocean trenches that mark the boundaries between tectonic plates all represent temporary features in the ongoing evolution of our planet's surface, destined to be replaced by new mountains, new islands, and new ocean basins, as the patient process of plate tectonics continues its eternal cycle. In contemplating these vast timescales and immense forces, we find perspective that places our daily concerns within the broader context of planetary evolution, where the urgent problems that occupy our waking hours represent mere instants in the grand sweep of geological time. The volcanic peaks that witness sunrise and sunset with unchanging silence, the ocean currents that flow with rhythms established millions of years ago, and the tectonic plates that move with imperceptible steadiness, all invite us to consider the patient persistence that characterizes the deepest processes of our Earth. As consciousness fades into the peaceful realm of sleep, imagine yourself standing on a quiet volcanic peak in the early morning light, surrounded by the vast expanse of the Pacific Ocean stretching to the horizon in all directions, feeling the solid rock beneath your feet that was built through countless eruptions over millions of years, breathing the clean air that carries the salt scent of distant oceans and the faint warmth of volcanic soils. The mountain stands in eternal silence, its slopes carved by countless seasons of rain and snow, its summit reaching toward the sky with the patient dignity that comes from geological time. And if this journey around the ring of fire has brought you closer to the peaceful sleep you seek, remember to subscribe to join us on future explorations of our planet's most magnificent yet soothing landscapes, where the grand processes that shape our world invite rest and renewal far from the concerns of daily life.